electricity. If you want to know more, keep watching this video.
It can strike without warning at any moment. You may be walking across a soft carpet and reaching for the doorknob when suddenly, zap! To understand static electricity, we first need to know a bit about the nature of matter. All matter is made up of atoms that consist of smaller particles, negatively charged electrons, positively charged protons, and neutral neutrons. Normally, the electrons and protons in the atom balance out, which is why most matter you come across is electrically neutral, but electrons are tiny and almost insignificant in mass, and rubbing friction can give loosely bound electrons enough energy to leave their atoms and attach to others, migrating between different surfaces. When this happens, the first object is left with more protons than electrons and becomes positively charged, while the one with more electrons accumulates a negative charge. This situation is called a charge imbalance or net charge separation.
But nature tends towards balance, so when one of these newly charged bodies comes into contact with another material, the mobile electrons will take the first chance they get to go where they are most needed, either jumping off the negatively charged object or jumping onto the positively charged one in an attempt to restore the neutral charge equilibrium. And this quick movement of electrons, called static discharge, is what we recognize as that sudden spark.
This process doesn't happen with just any objects. Otherwise, you would be getting zapped all the time. Conductors like metals and salt water tend to have loosely bound outer electrons, which can easily flow between molecules. On the other hand, insulators like plastics, rubber, and glass have tightly bound electrons that won't readily jump to other atoms. Static buildup is most likely to occur when one of the materials involved is an insulator. When you walk across a rock, electrons from your body will rub off onto it, while the rock's insulating wool will resist losing its own electrons. Although your body and the rock together are still electrically neutral, there is now a charge polarization between the two.
And when you reach to touch the doorknob, zap! The metal doorknob's loosely bound electrons hop to your hand to replace the electrons your body has lost. When it happens in your bedroom, it's a minor nuisance. But in the great outdoors, static electricity can be a terrifying, destructive force of nature. In certain conditions, charge separation will occur in clouds. We don't know exactly how this happens.
Coulomb's law. Coulomb's law states that the magnitude of the electrostatic force between two electrically charged bodies is proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. The formula is F equals K times Q1 and Q2 divided by square root of R, where F is the electrostatic force, Q1 and Q2 are the magnitude of 2-point charges, R is the distance separating the charges, and K is that constant, which is 9 times 10 to the power of 9. Electric field. An electric field is a region in which an electric charge experiences a force. Since nearby charges exert forces on each other, there are electric fields in the spaces surrounding them. To be able to find the electric field, the formula is E equals F divided by Q, when E is the electric field strength, F is the force, and Q is the unit charge. Electric potential energy. Electric potential energy of a charge at a point in the electric field is defined as the work done on the charge by an external force in bringing it from infinity to the point in the electric field. To be able to find it, you can use the formula V equals Q divided by 4 times pi times E0 times R, where V is the electric potential of a point. Q is the charge, R is the distance separating charges, and E0 is the permittivity of free space, which is 8.85 times 10 to the power of negative 12. But if we want to know the potential difference, you can use this one. W equals small q times V, where W is the electrical energy converted to other forms by the charge Q. Q is the charge that flows from A to B, and V is the potential difference between A and B.
Thank you very much for watching. We hope you enjoyed this video.
Goodbye!